In this video, we will be looking at functions, but in order to understand a function, the first thing that we need to talk about is a relation. So a relation is simply any set of ordered pairs. Now, typically they have the values there have some type of relationship, which the name implies. So maybe it's a person and their birth date. That could be an example of a relation. So everybody would have a name and a birth date that would go together. You could also have something like the number of miles driven in a month and the cost to drive that many miles. So that would be a relationship. You could have the number of students in a class and how long it took to grade papers. That would be a relationship. But a relation is just any set of ordered pairs. The set of all the first components of the ordered pairs is called the domain of the relation. And the set of all the second components is called the range of the relation. So we have an example of a relation down here. We have the ordered pairs 1, 2, 3, -4, 1, -8, and -5, 1. And we want to find the domain and the range of the relation. Now, we can give domain and range in any set notation that we choose, but depending on how we've been given the relation, that's going to dictate the easiest option for giving the domain and range. In this case, notice that we were given a set number of ordered pairs in roster form. So we are going to give our domain and range in roster form as well. So the domain, which I'm just going to abbreviate as DOM, is made up of all of the first components. So from the first ordered pair, it would be 1. Second ordered pair would be 3. Third ordered pair would be 1. And fourth ordered pair would be -5. And because the 1 occurs twice, we actually don't have to complete it or include it in the domain twice. So our domain would just be 1, 3, and -5. So let's move that -5 over a little bit more. Now, if you will notice that in this case, the first component of an ordered pair always represents what? It represents X, or the X value. So oftentimes we will say that the domain of a relation is made up of the X values. The range, on the other hand, is made up of the second components of each set. And so if you think about it in terms of ordered pairs, the second component of an ordered pair is made up of the Y values. So we often say that range is made up of the Y values. So in this case, the range is made up of 2, -4, -8, and 1. So our domain is 1, 3, -5, and our range is 2, -4, -8, and 1. And I'm having a little trouble getting my brace drawn here. Okay. So now that we understand what a relation is, now we can take a look at what a function is. So a function is a specific type of relation. So a relation in which each member of the domain, so each X value, corresponds to exactly one member of the range, or Y value, is called a function. So a function is a specific type of relation in which every domain value must correspond to exactly one range value. So if we go back up here to our previous example, we said it was a relation, but is it a function? And the answer is no, because 1 corresponds to 2, but 1 also corresponds to -8. So since 1 does not correspond to exactly one member of the range, it corresponds to two different ones, then this would not be a function. So let's look at some other examples here, and let's determine whether or not they are functions, and then if they are, we're going to find their domain and range. So we look at A, we have the ordered pair 1, 4, 2, 5, 3, 6, and 4, 7. So X value of 1 corresponds to 4 and only 4. There are no other 1s corresponding to any other number. 2 corresponds to 5 and only 5. 3 corresponds to 6 and only 6. 4 corresponds to 7 and only 7. So yes, this is a function, and we can find the domain and range. So domain is made up of all of the X values, so all of the first components in the ordered pairs. So the domain in this case is going to be 1, 2, 3, 4, because that represents the first components in each ordered pair. And then the range is going to be all of the second components. So in this case, 4, 5, 6, 7. So now let's look at B. The first thing we want to do is to determine whether or not it is a function. So we look and we see that 1 corresponds to 4 and only 4. 2 corresponds to 4 and only 4. 3 corresponds to 5 and only 5, and 6 corresponds to 10 and only 10. And a lot of times people will try to tell me that this is not a function because 1 corresponds to 4 and 2 also corresponds to 4. But remember, our definition of a function doesn't say anything about the same members in the range. It just says that each member in the domain can only correspond to one member in the range. So it doesn't matter that 1 and 2 both correspond to 4. As long as 1 corresponds to 4 and only 4, it's still a function. So in this case, this would be an example of a function. Its domain would be all of the X values, or the first values. So 1, 2, 3, and 6. And then its range would be all of the Y values, or the second values. So 4, no need to write 4 a second time, 5, and 10. So looking at our last example here, we have the ordered pairs -3, 9, -2, 4, 0, 0, 1, 1, and -3, 8. And I can quickly go, uh-oh, this is a problem. This is not going to be a function because -3 corresponds to 9 in this ordered pair, but -3 corresponds to 8 in this ordered pair. And anytime that the same X corresponds to different Y's, what we have is not a function. So in this case, there's no need to find the domain and range because this would not be a function.